By the 1920s, Salvarsan was the world's most popular drug, particularly with men. But Ehrlich's hope that it would be just the first of many magic bullets proved ill-founded. Infections caused by the most minor of injuries were still uncontrollable.
People frequently died of infection, and things like puerperal sepsis. Women died after delivering their children.
Septic wards were gruesome places, filled with the sick, the dying, and the desperate.
There were people with severe and chronic infections who tended to be there for sometimes weeks, with pots under their beds draining the pus from various abscesses or infected wounds.
Cleaning the wound of pus was the only way doctors, or more likely nurses, had of fighting infection. Pus is the debris left behind when the white blood cells of our immune system take on invading bacteria. But it can also become a nice, cosy home for the bacteria, a constant source of reinfection. By draining pus, doctors hoped to prevent infections reaching the blood. Because once that happened, the prognosis becomes incredibly bleak. Half of those who went into a septic ward never came out alive. But that would change thanks to the chance discovery in 1928 of a mold with remarkable antibacterial properties, penicillin. Most people learn at school that it was Alexander Fleming who was responsible for penicillin. Well, this is only partially true.
Alexander Fleming, he'd hailed from Scotland. He was a very bright student. Eventually he won a scholarship to St Mary's Medical School and prospered there, and stayed on at St Mary's because he was a good sportsman, and he particularly was a good shot, and they wanted him for their shooting team.
When he wasn't shooting, Fleming spent much of his time in the lab, studying staphylococci, bacteria that are commonly found on skin. And then, in August 1928, Fleming went away on holiday. When he returned, he started to examine some Petri dishes which he'd previously seeded with bacteria. And he noticed something very odd. An uninvited fungal mold.
Well, I want to show you the original cultivation, which I kept. Here's the mold, and above you've got the staphylococcal colonies, but close around the mold, the colonies have disappeared.
Normally, bacteria grow new cell walls before they divide. But the mold produced a substance that prevented new cell walls being made. The bacteria were unable to divide and eventually burst open, like a balloon. Fleming was lucky. It's likely that the penicillin mold had blown in from a nearby lab where they were studying fungi. But contrary to legend, he really didn't make the most of his remarkable break.
He didn't really realize what he was onto. He made one very short comment in his first paper that said maybe this could be injected into the sites of infection. But he never did that himself, and he never followed it up. So I have him down as an acute observer, but not a genius, as he's often been portrayed.
It also didn't help that he was an absolutely terrible public speaker and was completely unable to enthuse others. For these reasons, the most powerful life-saving fungus the world has ever known, well, for many years it just languished in the dark. And there it would remain until 1938, when researchers here at the Dunn School of Pathology in Oxford would rediscover penicillin and turn it from a medical curiosity into the greatest life-saving drug the world has ever known. The storm clouds of the Second World War were beginning to gather over Europe, 20 years after the end of the First.
We know that during the First World War, more troops died because of wound infection than because of direct hits by enemy fire.
In Germany, scientists had discovered the antibacterial properties of the sulfonamides. And with the prospect of more bloodshed on the horizon, a small team was assembled in Oxford to find a British germ-killing agent. The team had stumbled across Fleming's original penicillin paper, and by a remarkable chance, there also happened to be some penicillin mould in the building. The team consisted of 3 very different characters, led by an abrasive Australian doctor called Howard Florey. This was his office.
Florey's talent was as a team leader and a designer of experiments, and he was the guy who'd organised the team and brought in the various specialties.
He recruited 2 very different assistants. Ernst Chain, an excitable Jewish refugee who'd fled the Nazis, and Norman Heatley, a keen sailor from Suffolk.
So Chain was trained originally in Berlin and was generally regarded as a high-class biochemist. Heatley was an expert at micro techniques, and he was very good at making equipment, producing things out of bits of wood and bits of rubber tubing.
In 1939, war broke out in Europe. With wounded British troops dying in France, there was mounting pressure on the Oxford team to come up with answers. Trouble was, penicillin was proving hard to grow and even harder to purify. Unlike Fleming, Florey's team had managed to extract the active chemical, and they had tested it on bacteria. Now they needed to test it on a living creature. In this lab in May 1940, they did the first really important experiment. They got 8 mice and injected them with a lethal dose of Streptococcus, a bacteria. And then they injected 4 of the mice with penicillin and waited to see what would happen. Well, Norman Heatley kept a diary, and this is what he wrote. I stayed at the lab till 3:45, by which time all 4 control animals were dead. The ones given penicillin, however, were all still alive. Now, I'm sure Heatley recognised this was a massive moment, but what he wrote in his diary was, I discovered I had put my pants on back to front. A lucky omen. Florey was more obviously enthused, saying, it looks like a miracle. And this was not hyperbole. Never before had anyone seen an effective germ killer with so few side effects. But the team now had to find ways to produce enough of it to test on a human.
Florey made the comment that humans are 3,000 times bigger than mice, and so we're going to need 3,000 times more penicillin than we had for these experiments.
And so, during the summer of 1940, as France fell to the Germans and Britain feared invasion, the entire staff of the Oxford School of Pathology was enlisted to help make penicillin, with, amongst other things, bedpans. Trying to make larger amounts of penicillin in this building with very little money and in the middle of a war was an absolute nightmare. What were they going to do about equipment? Well, they had to improvise.
They found they could grow the penicillin mould in bedpans and then skim it off.
It was a real Heath Robinson affair, made out of a bath, milk churns, an old bookshelf apparently from the Bodleian Library. And they made pretty rapid progress. But before seeing if it could cure, they needed to make sure it wouldn't kill. Just because it worked in mice didn't mean it would work in humans. They needed someone prepared to take a potentially fatal dose. Mrs. Elva Ackers, a 50-year-old housewife, was asked to help. She had terminal cancer, and she was told that the penicillin would do her absolutely no good. It might indeed push her over the edge. Nonetheless, she volunteered, saying she was proud to help. The penicillin used was extremely impure. I think we now know that what went into the first patient was about 3% penicillin and 97% impurities.
On the night of January the 27th, 1941, Alva became the first human to be injected with penicillin. After a few days, the team concluded it was safe. Now they needed to find a patient it could actually help. Just a few doors down from Alva, in the same hospital, a man was fighting a particularly hideous infection. It had started following a minor accident. Albert Alexander, a 43-year-old police constable, was out gardening one day when he got scratched on the side of his face by a rose thorn. Or at least that's how the story goes. Whatever caused the tiny wound, it soon became horribly infected. And Albert was consigned to one of the hospital's notorious septic wards. This is Albert, healthy, good-looking young man. And this is Albert in hospital. He's a complete wreck. His left eye has gone, he's covered in abscesses, and his lungs are full of purulent matter. This is draining pus from his right eye. He really only has one hope: penicillin. On February the 11th, 1941, Albert was given the first dose. Over the next few days, Florey and his team constantly monitored him for any sign of improvement.
He made what seemed to be a remarkable recovery. His temperature came down, he started to eat. I think he even got out of bed. He was much better.
The penicillin was clearly working, which was fantastic. Unfortunately, they didn't have enough of it. So in desperation, they collected his urine and extracted from it the penicillin that his body hadn't used. But it was all too little, too late. A month after starting treatment, Albert Alexander died. Sad though the death of Albert was, his initial dramatic recovery suggested penicillin could be the miracle drug the country needed. And one of the fears now was it might get into German hands. Penicillin was extraordinary stuff, but these were also extraordinary times. There was a serious fear that Britain would be invaded, and if so, they would have to destroy all their work rather than allow it to fall into enemy hands. So they smeared spores on the inside of their coats.
So that if they were forced to escape from Oxford, they could actually take the mould with them and start the work again. So that gives some sense of the importance that they ascribed to this work.
The conviction of the group was that their discovery was so important it was potentially capable of changing the course of World War II.
But if the entire Dunn School, working for months, couldn't make enough of the stuff to save one man, then it wasn't going to help anyone.
So that was why Florey realised the importance of upping production. But in fact, he couldn't get the British pharmaceutical industry to become involved. They were fully occupied doing things for the war effort. And so in a sort of frustration, he decided he'd have to go to America.
In July 1941, Florey and Heatley arrived in New York, carrying the penicillin molds in a briefcase. They told immigration they were on medical business. With the help of the Rockefeller Institute, Florey and Heatley were introduced to the country's biggest chemical companies. Unlike their British counterparts, they quickly realized the drug's potential.
The war was causing casualties that led to infections, that led to death. Penicillin clearly was a winner. The question was, can we get it to the troops a sufficient quantity and in time?
Now they were here, there were three problems they needed help solving. Firstly, find something the mold really liked growing in. Secondly, find a more powerful strain of the mold. And finally, improve the production process. Well, The first problem was soon solved because it turns out that penicillin mold really likes this stuff, corn syrup. Sweet and sticky. They liked it almost as much as we do. Unfortunately, the Americans had lots and lots of it. The other two problems were rather harder to crack. The problem with the penicillin mold they were using was it was still based on Fleming's original mold. Maybe there were even more powerful molds which could produce more penicillin. An international search was launched, and samples of mold found anywhere and everywhere in the world were flown to the US labs by military transport. Scientists worked around the clock testing them, but none gave the yields needed. Perhaps a more powerful strain simply didn't exist. And then there was a wonderful twist. Now, the story goes that a woman called Mary Hunt, who worked for the US Department of Agriculture, was wandering through the fruit markets, as she often did, looking not so much for fresh fruit as for something really rotten. And one wonderful day, she came across this. A moldy melon. And they took this off to be tested, and it turned out that the mold was a really powerful source of penicillin, so much so that for a while it became the source of almost all the world's penicillin. But despite these improvements, the inefficiency of the actual production process meant that by 1943 there was still only enough penicillin to treat a lucky few.
The standard techniques were large, wide-bottomed flasks. Because you had a single layer of mold producing, the yields from each flask were minimal.
And the need for penicillin had never been more urgent. D-Day, the greatest amphibious invasion in history, was only months away. Casualties were going to be horrific.
Penicillin was the US military's second top research priority after the Manhattan Project, after nuclear weapons.
It was then that a small chemical company based in this building in Brooklyn called Pfizer got involved. Now, these days, Pfizer is better known for its anti-impotence drug, Viagra. But back then, they produced citric acid used in fizzy drinks. Now, they realized, as everyone else had, that if you just grow penicillin on the surface of a liquid, then that is going to be really inefficient. What you want to do is grow it throughout the liquid. The problem is that penicillin needs oxygen to grow. So they came up with a solution which they hoped would work.
The oxygenation came with a tube introduced into the medium into which oxygen was pumped. But you couldn't put too much and you couldn't put too little. So learning how much was right was key.
There was absolutely no guarantee the technique would work. But the company took a gamble. Because of wartime shortages, they had to convert an old Brooklyn ice factory, scrounging a boiler from Indiana and a lift from Long Island. With just 2 months to go before D-Day, they installed 14 giant fermentation tanks. Then they added the corn syrup and the cantaloupe mold before turning on the air. The results were spectacular. They soon began producing 5 times as much penicillin as originally planned. By June 1944, the D-Day invasions, there was enough penicillin for every injured soldier. And most of it was produced right here in the Pfizer plant in Brooklyn.
Penicillin was successfully developed in time to hugely influence the outcome of World War II.
Protracted hospitalization from infected wounds was almost eliminated amongst Allied soldiers. Many could be back on the front line with a rifle in their hand within weeks. For others, it made once lethal wounds survivable.
Thousands of men, thanks to penicillin, will come home to their thankful families. Science has won another victory over death.
Hopes were high and largely justified. These pictures show a little girl going from death's door to happy in just a few days. No longer would a scratch from a rose thorn or a minor cut lead to a hideous death. Now, it all started with Alexander Fleming and his chance observation, but without Florey and the Oxford team, who knows when the mould would have been made into a safe and effective drug.
In summary, I would say that the work of Florey's team, particularly Florey, Chain, Heatley, resulted in the greatest medical advance of the 20th century and gave us a new way of looking at the treatment of infectious diseases.
Penicillin heralded the dawn of the antibiotic age, and in the years that followed, further antibiotics were discovered and developed that made the incurable curable and changed what was once fatal into no more than a minor illness.
Prior to antibiotics, prior to penicillin, we really did live in a world where you could be young, fit and healthy one day, get a cold the next and be dead by the end of the week.
For the first time in human history, we seem to have the germs on the run. But the battle against bacteria represents only a part of the story of our fight against infection, because antibiotics, spectacular though they are useless against viruses. And viruses, in many ways, presented an even greater challenge.